See, look at this question. 75 gram of sugar solution has 30% sugar in it. Then the quantity of sugar that should be added to the solution to make the quantity of sugar 70% is in the solution is. See what we are doing here. We are adding sugar to it. So let us draw a diagram first. How many grams of content solution is there? 75 grams. In that 75 grams, what is the sugar content? The sugar is 30%. This is sugar. They give 30%. And the remaining is water. The water is 70% is water and 30% is sugar. In the second case, what happened? The quantity of sugar that should be added, the water remains same, but we are increasing the quantity of sugar so that its percentage will become 70%. This is now in the second case, this is 70% of sugar and the water is 30%. This is the new solution. In first case and second case, the quantity of sugar varies, but the quantity of water remains same. So what we can say, the quantity of water in the first case is 70% of 75 must be equivalent to quantity of water in the second case 30% of n. Let us the new solution be n. On simplification you will get n equivalent to, see here, 0 0 get cancels, 3 ones 325s, 7 into 25 which is equals to 175. The new solution has become 175. This 75 grams has become 175 because we are adding sugar of 100 grams. So the answer is option 2. Now 40 liters of a mixture of milk and water contain, here it is 10%. 10% is of water. The water to be added to make the water content 20% in the new mixture is. In this case, see here, milk and water. This is, let us say, milk and the water is this. How many liters is there? 40 liters. Now what is the water content? 10%. What is the milk content? 90%. In the new solution, it means we are adding water. Okay. Now the water percent has become 20% and the milk is will become 80% because you are adding water. If you observe both the case, what is constant? The quantity of milk is constant. We have to equate the quantity of milk. So 90% of first solution, which is 40 liters, must be equivalent to, in the second solution, what is the milk percentage? 80%. 80% of new solution. On simplification, you will get n equal to 45 liters. So this has become 45 liters because we are adding 5 liters of water. Simply the answer is option 4. Why you are adding 5 liters of water? Because the condition is you have to make the water as 20% in the given content. Next, see here, 200 liters of a mixture contains 15% of water and the rest is milk. The amount of milk that must be added so that the resulting mixture contains 85% of the milk. Simple. What you have to do? The quantity of water remains same in both the cases because you are adding only milk. The water quantity remains same. We have to equate the water quantity. So in the first mixture, what is the water percentage? 15% of 200 liters must be equivalent to. In the second solution, the new solution, what is the milk percentage? 87.5. The remaining is 12.5% of new solution. So we are equating the quantity of water, okay, because we are adding water here, milk here. It means the quantity of water remains same. Even though the percentage changes, the quantity of water remains same. 12.5 ones, 12.5 sixteens. So n equivalents to 240. The new solution is 240. What is the initial solution? 200 liters. How much extra is adding? 40 liters. Simply the answer is option 3. The ratio in which two sugar solutions of the concentrations 15% and 40% to be mixed to get a solution of concentration 30%. How to solve this? Assume that 15% solution you are adding x liters and 40% of solution we are adding y liters. Now what happens? Let us equate the percentages. 15% of x plus 40% of y. I am taking sugar solution both the case. Divided by what is the total quantity? X plus y, because we are taking x liters from the first one and y liters from the second one. So that the percentage will become how much? 30%. So 15% of x plus 40% of y equal to 30% of x plus y. From this we can say that 15% of x is equivalent to 10% of y. Simply x by y equivalent to 2 by 3. The answer is option 1. What is the other easy method to do this? In one go you can do this. See, what is the lowest percentage? 15. What is the highest percentage? 40. What is the required percentage? 30. Simply take the difference here. What is the difference? 10. Here, what is the difference? 15. Simply you get the ratio directly 2:3. Okay, either you can go this method or that method. Price of a sugar rises by 20%. By how much percent should the consumption of sugar reduced so that the expenditure does not change? See here, when your expenditure is equals to price into consumption. To make this one variable constant, see, if one variable is increased by r percentage, the other variable must be reduced by r by 100 plus r into 100%. Okay, simple. 20% rises, it means the consumption must be reduced by r is equal to 20 is given. The consumption must be reduced by 20 by 120 into 100, which is equivalent to 0 0 get cancels, 2 1s 2 6s. 100 by 6 is nothing but 16. 2 by 3%. The answer is option 3. If food prices go up by 10%, by how much should a man reduce the consumption so as not to increase his expenditure? So I have to keep expenditure constant. So expenditure is nothing but price into consumption. Expenditure is increased by 10%. So the consumption must be reduced by 10 by 110 into 100. 0 and 0 will get cancels. This is nothing but 100 by 11%. So which is nothing but 9 1 by 11%. Simply the answer is option 1. In the new budget, the price of a kerosene oil rose by 25%. By how much percent must a person reduce his consumption of kerosene oil so that his expenditure on it does not increase? Expenditure is equals to price into consumption. Expenditure is increased by how much? 25%. The consumption must be reduced by 25 by 100 plus 25 into 100%. This is what you have to reduce by. You have to reduce consumption. So on simplification, you will get 25 ones, 25 fives, 5 ones, 5 20s, which is equals to 20%. Option 1. If the rate of it, if the price of tea is increased by 20%, by how much percent the consumption of tea will be reduced so that there is no increase in expenditure on it? There is no increase in the expenditure on it. Simple. Expenditure is equivalent to price into consumption. If expenditure is increased by price is increased by 20%, the consumption must be reduced. So 20 by 120 into 100, that is nothing but 16 2 by 3%. The consumption must be reduced by 16 2 by 3%. So option 3 is an answer. The price of a commodity decreased by 20% and its consumption is increased by 20%. what will be the percentage increase or decrease in the expenditure of the commodity? Simple. Expenditure is expressed as price into consumption. If price is changed by X percentage, commodity is changed by Y percentage, then the change in expenditure, let us say delta E, change in expenditure is nothing but X plus Y plus XY by 100. See, we are using the word change. Change is nothing but a change means it may increase or decrease. If it is an increase, take positive. If it is a decrease, take negative. Okay. Now here, read the question carefully. The price of a commodity decreased by 20%. It means X is equivalent to minus 20. And the consumption is increased by 20%. C equivalent to plus 20. What will be the increase or decrease in the expenditure on the commodity? Simple. Minus 20 plus 20 plus minus 20 into 20 by 100, which is equals to minus 4. So 4% decrease. The expenditure is decreased by 4%. Option 2. See, negative sign indicates decrease. The price of a certain item increased by 15%. If a consumer wants to keep his expenditure on the item the same as before, how much percent must he reduce his consumption of that item? Expenditure is equivalent to price into consumption. If price is increased by R percentage, then the consumption must be reduced by R by 100 plus R into 100%. That to decrease. Now is given that R equal to how much is given? 15. So the consumption must be reduced by 15 by 115 into 100. 5 3s, 5 23s, which is nothing but 300 by 23. On simplification, you will get 13 1 by 23%. Simply option 2. If the duty on an article is reduced by 40% of its present rate, by how much percent must its consumption increase in order that the revenue remains unaltered? Revenue here is nothing but price, okay, into consumption. Price into consumption. The what is the reduced here? 40% is reduced. So the consumption must be increased by 40 by 100 minus 40 into 100. That equals to 40 by 60 into 100. That equals to for 66 2 by 3%. So option 4. Simple. If any variable is expressed as a product of other two variables, if one is decreased by R percentage, to nullify that effect, the other one must be increased by R by 100 minus R into 100%. Okay. If one item is decreased, to nullify that, the other item must be increased. How much percentage? R by 100 minus R into 100%. Here what is R given? 40. Decreased. So we have to increase the other variable. So that is 40 by 100 minus 40 into 100. On simplification, you get 66 2 by 3%. In an examination, there were 1000 boys and 800 girls. 60% of the boys and 50% of the girls passed. The percent of the candidates failed. How many boys are there? Total boys are how much? 1000 and total girls are 800. Straight away, what is the total? 1800. Simple. What is asking? Find the percent of the candidates failed. Let us directly concentrate on the failed people. If 60% of the boys passed, it means how many failed? 40%. How many boys are there? 1000. So these are the failed in boys category. And failed in girls category, how much? 50%. 50% of 800. Because the passed is 50% and fail will be 50%. Here what is the fail? 40%. That is what we are writing here. Okay. Now this is equivalent to 40% of 1000 is 400. 50% of 800 is 400. The total is 800 by 1800 into 100. 0 and 0 will get cancelled. 2 4s and 2 9s. So 400 by 9, which is nothing but 44.44. The answer is approximately 3.